Hi, this is Mr. Curtis, and today's topic is going to be evolution. But before we get into that, let's go through a few of the basic terms. So first of all, the definition for evolution that we're going to use is this: a slow, gradual change in living things over millions of years. Here are some other terms that we need to go through, starting with a fact, which is an idea that most people agree is true. Now notice I say most people because here's an example. This is the Flat Earth Society. Yes, this is a website from the Flat Earth Society, and it's a group of people assuming that they still believe that the Earth is flat. So even if we can mostly agree on a fact, there always will be some people that will disagree. Some other terms to go through. A theory is an explanation for a scientific concept. The information for a theory has been collected to explain it. Most scientists agree with the explanation, and the explanation might not be complete. Next, let's look at what fossils are. Fossils are a preserved remain of a living thing. How do fossils form? Well, when something dies, and it oftentimes gets buried, there will be some things that decay quicker than other things. And one of the last things to decay is going to be the bones. Now, if the conditions are just right, the bones won't decay, and over the years, more and more soil will form over the top of it. Layer upon layer upon layer will form. And as those layers form, you have a tremendous amount of weight that builds up on those bones. As the weight builds up, the minerals in the soil will push into the bones and cause it to, as they say, completely mineralize. And when that happens, you end up with a fossil. These are structures that are stone, but yet they take the shape of the thing that of the bone, and so that way you get here this big thing. The fossil record is made up of all the fossils ever discovered on Earth, and there literally has been millions and millions of fossils found. Now, the fossil record, how do you determine the age of a fossil? Well, there's two ways. Now, consider this. Here's a garbage dump, and if you think about a garbage dump, it's just this big, huge bowl, and on the bottom here you have a cap of something called clay, and the idea is that nothing can get through that clay bowl there. And as the garbage is brought in, what happens? Well, you get this layer of garbage. This was yesterday's, and this was the day before. Okay, more than just yesterday. And as you get more and more and more garbage that piles up. Now think about it. Where would you find the oldest garbage? Well, the stuff that was put in first. So down here is going to be the oldest stuff. Well, you can think of fossils as the same way. The deeper the fossil, the older it will be. This is called relative age dating. So the deeper it is, the older it is. There's another kind of dating that's called absolute age dating. And in this, oops, wrong button. And in this, what they do is they'll take a fossil, let's say that this is a piece of it, and they look to see how much radioactivity is in it. And by looking how much radioactivity something has, they can determine its age. So the more radioactive it is, the younger it is. And as something gets older, it will have less radioactivity. We'll talk more about that in class rather than do it right here. All right, let's move on to the basics of the evolution theory. First of all, evolution says that the children of living things are slightly different. Think about your own family. If you have brothers and sisters, you have some things that are in common with them, the way you look, but not exactly. So consider this famous family here. Some children will have an advantage over others. They will be more likely to survive and have kids of their own. This is known as natural selection. Now, what that advantage is, we don't know. It might be intelligence. It might be gender. Sometimes certain genders have an advantage over others. Maybe it's size. Who knows? But whatever the advantage is, some will have that, and they are more likely then to have kids of their own. This is called survival of the fittest. The advantages then will be passed on to other generations, slightly changing the species. These changes accumulate over a long period of time, and eventually you get a change in the species. That change leads to evolution. An adaptation is an inherited trait that increases the chance of survival. Those things that can cope will survive. Others become extinct. Now you think about the poor dodo bird. Here's an animal that could not cope with the changes that happened on that island that they lived in. They had ground nests. They only produced one egg. And so when humans came in and they had pigs on the island, the pigs ate the eggs of the dodos on the ground, and eventually no eggs, no babies, no more babies, no more dodos. Charles Darwin, he is the guy who developed the theory of evolution. He lived in the 1880s, and oh, by the way, he has the same birthday as Abraham Lincoln. Little trivia there. Here's some of the evidence that is used for evolution. So evolution says that animals that are extinct have bones that are similar to today's animals. Now this is a picture of T-Rex. What does T-Rex kind of look like here to you? What kind of modern day animal? Similar bones means that there are similar ancestors. Here's another example. Anyone know what this animal is? Yes, this is a bat. And if you look at, I want you to focus on the wings of this bat. Count how many fingers there are. Well, there's 5. How many do you have? Look at here. This would be the forearm. How many bones are there in your forearm? Look at this. Here's a shoulder plate. Right there. That's the scapula. Right there, excuse me. Here's the clavicle, collarbone. Now you compare that to our forearm. We have, look here, we have 2 bones in our forearm, and we have 5 digits. So similar structures means similar ancestors. Here's another comparison. When they're similar structures, these things are called homologous. Homologous structures. Other evidence that's used for evolution. Something called DNA. DNA is the instruction booklet used for all living things. And it literally is what it says. DNA is this molecule inside of you that will produce proteins. And you are made of nothing more than a bunch of proteins. And eventually, from those proteins, you are made. So DNA literally is your instruction booklet. Well, if you look at DNA, similar DNA means similar ancestors. So obviously these 2 lovely looking gentlemen, handsome dudes, nice boots there, dyes, and I love that green shirt. Obviously they have a similar ancestor, both the same parents. But if you compare, for example, a gorilla and a human, well, how much DNA do you think they have in common? Now, I want you to take a guess. If you say 0%, you're saying that there's nothing in common. They don't have any features that are similar. If you said 100%, that means that we are exactly the same as gorillas. So I want you to, on your paper now, I want you to write down what percent you think we have in common. And the answer is 98.4% in common. Amazing. Now, a couple other things about what evolution says and what it doesn't say. Many of you have seen a picture like this before, and many of you have heard that evolution says that man came from apes. Actually, that's not what evolution says. In fact, this is one of the main things this whole year that I hope you remember, is that evolution says that we did not come from apes. What does evolution say? Evolution says that years ago there was some common ancestor. Who knows what it was? And from that ancestor came different groups of similar animals. Monkeys became one family. Apes became another family. And humans became another family. So we have different family members. We have a common ancestor, but we're not directly related to monkeys, apes, and so on. Other things that evolution says. Evolution cannot be predicted. We don't know what's going to be the next thing. It all depends on what animals have to adapt to. Changes in the environment, whatever. Evolution has no direction. So that doesn't happen to have, we don't go from simple animals to more complicated animals. Today's ants are not going to be tomorrow's poodles. Not necessarily. It does not go from simple to complicated, like I said. And 99% of all species that have ever lived on Earth are extinct. Think about that for a minute. The saber-toothed tiger, all the dinosaurs, the dodo bird, the passenger pigeon, all those animals, ivory-billed woodpecker, these things have all become extinct, but that's normal. Extinction is normal, and all species eventually become extinct. And evolution is still happening today. We'll talk about many things in class about examples of how things are still evolving today. Okay, so now you're finished with this. Now what I want you to do is look over your briefs and highlight the most important things in the briefs column, and also don't forget to put a 2 to 3 sentence summary at the bottom of your sheet. And we'll see you next time.